Right now, somewhere out there, a road is literally melting under the heat. Half of Europe is baking, fans are sold out, nobody can sleep, and you right now watching this, you feel it too. This is probably the hottest you've felt in years, so let me ruin that for you. Because the worst heat wave in human history is a cool morning compared to what's out there. Out in the universe, there are places so hot they wouldn't burn you, they would erase you. Places where the heat melts metal and boils away whole oceans, and places that bend the rules of what a temperature can even be. So how hot does it really get out there, and what would these places actually do to a human body? We'll start with a hot summer day and end somewhere that makes the sun itself look freezing. No suit, no shade, no escape, just a human body and a universe on fire. Stay with me, because the very last place on this list isn't even something you could ever see. First, before we leave Earth, let's talk about you, because your body is shockingly fragile when it comes to heat. Your insides sit at a steady 37 degrees Celsius. That one number is the whole game. It's the line that keeps you alive. Push it up by just a few degrees and everything starts to fall apart. At 40 degrees inside, you'd be in serious danger. Heat stroke, confusion, your body's careful controls all breaking down at once. That's a mere heat wave doing it. The thing crawling across cities right now, and it tops out at maybe 50 degrees. 50 degrees feels apocalyptic to us. Hold that number in your head. We're about to leave it in the dust. Now, the hottest air temperature ever reliably recorded on Earth was about 56 degrees. It happened in Death Valley, a place so hostile it barely lets anything live. And that single number is already enough to kill an unprepared human in a matter of hours. So that's where your fragile body sits. Now look up, because the universe is about to laugh at these numbers. Let's start gentle with the planet everyone dreams of visiting, Mars. The red world we keep promising to call our second home. On a good summer day near the Martian equator, the ground can warm up nicely. You can actually reach a pleasant 20 degrees on the sunlit sand. So far, it sounds like a perfectly nice afternoon. Here is the catch that ruins it completely. Here's the catch. That warmth is only down at your feet. At head height, in the very same moment, it can be freezing cold. The air is so thin it can't hold or spread the heat, so warmth never wraps around you the way it does down here. And when the sun sets, Mars turns truly vicious. Temperatures crash to minus 70 degrees and far beyond. At the poles in winter, it gets so cold the air itself freezes and carbon dioxide falls as snow. So Mars teases you with a warm noon, then freezes you the instant the sun dips below the horizon. It's easily the friendliest world on our whole trip, and even it would still quietly kill you in a single night. So let's turn up the heat. Now we move closer to the sun, to the little planet right on the front line. This is Mercury, the planet that takes the sun's full, unfiltered blast. Mercury is a tiny world with no real air to protect it, so the sun's rays slam into the ground completely unsoftened. In the daytime sun, the surface roasts to 430 degrees Celsius. Remember that 50-degree heat wave that scared us so much? This is more than 8 times hotter. Just let that sink in. It's hot enough to melt lead, tin, and zinc into glowing silver puddles right there on the rock. Standing here unprotected, your skin would char in mere seconds, and your blood would boil away in the airless heat, with no air pressure to hold it. And here's Mercury's cruel twist. Step into the shadow, and you don't cool down, you freeze. In the shade, with no air to hold any warmth, the heat just vanishes. It crashes to 180 degrees below zero. 600 degrees of difference, sometimes within a single step, roasted on one side, frozen on the other. But Mercury is only the warm-up act, because the next planet should be cooler, and instead it's pure hell. This is Venus, and it breaks every rule you'd expect about heat. Venus is farther from the sun than Mercury. By every rule it should be cooler. It is not. Venus is the hottest planet in the entire solar system, around 465 degrees, everywhere, all the time. Day, night, pole to pole. Hot enough that the rock on the ground glows faintly red, like the inside of an oven that never cools. So why on earth is the farther planet the hotter one? The answer is one single word: atmosphere. Venus is wrapped in a thick, heavy blanket of carbon dioxide. Sunlight gets in easily, but the heat can never ever get back out. It's a greenhouse effect gone completely out of control. The worst one anywhere in the solar system, and the heat isn't even the only thing trying to kill you. the air itself would crush you. At the surface, the pressure is 90 times stronger than Earth's. It's the same brutal crush you'd feel a kilometer deep in the ocean. And drifting high above, clouds of pure sulfuric acid, the kind that eats straight through metal. So on Venus, you would be cooked, crushed, and dissolved all at the very same moment. We know this for certain because we actually sent machines down there to look. The toughest probe ever built survived just 2 hours before Venus completely destroyed it. 2 hours. That is how long the strongest thing we have ever built lasted down there. A fragile human body? You would last only seconds. Venus is a warning. It's basically what runaway heat does to a planet that started out a lot like Earth. Now let's leave our cozy little solar system, because out among the other stars, it gets so much worse. Out there, astronomers have found planets so close to their star that a year lasts only a few hours. Hugged that tightly against a furious sun, these worlds don't just get hot, their entire surface melts. On one famous lava planet, the day side sits around 2,400 degrees. Rock runs like water. It's so hot there that the rock itself boils, lifts into the sky, and falls again as glowing rain made of stone. Imagine standing in a storm where every raindrop is a bead of liquid lava. That's a real place out there. Now here's something genuinely strange. You don't have to travel to a hot planet at all to face killer heat. You can make your own inferno right here at home just by falling back to Earth too fast. When a spacecraft comes home, it doesn't gently glide down. It slams into the air at around 25 times the speed of sound, and the air simply can't get out of the way fast enough. So it gets violently squeezed. And squeezing air, it turns out, makes it blazing hot. A wall of superheated gas forms in front of the ship, reaching around 1,650 degrees. That's hot enough to vaporize solid steel. And it's all happening just centimeters from the astronauts strapped inside. The only thing between them and that fire is a heat shield designed to slowly burn away on purpose. As the shield burns, it carries the heat away with it, keeping the crew alive by mere inches. Get the angle even slightly wrong, and that fire stops being a shield and becomes a furnace. For a few terrifying minutes, the heat also cuts off all radio. Mission control can only wait and hope, so you don't even need an alien planet. Fall fast enough and the sky itself turns into a blowtorch. So how does anyone survive heat anything like this? The answer is one of the cleverest machines humans have ever built. The spacesuit. Out in direct sunlight in space, a suit gets hit with two extremes at once. Brutal heat on the side facing the sun and freezing cold on the side in shadow. But the real problem isn't the sun outside. Surprisingly, it's the heat the astronaut makes inside. Here's the surprise. A working astronaut's body pumps out a huge amount of heat, as much as a bright light bulb, with nowhere for it to go inside a sealed suit. Trapped in a sealed suit, that heat would cook the astronaut from the inside in a matter of minutes. So engineers wove a web of thin tubes through the underwear with cool water flowing through it. The flowing water soaks up the body's heat as it passes by the skin. Then it carries that heat away and dumps it straight out into space. A wearable radiator. To dump that heat, the suit uses a trick called sublimation, letting a little ice turn straight to vapor and float away. It's so good at its job that the danger usually flips. Astronauts often get too cold, not too hot. A thin layer of fabric and flowing water is the only thing standing between a human and the fury of the sun. Now we leave the planets behind entirely, and we go straight to the source of nearly all this heat, the sun. Every hot thing we've seen so far is just sunlight, weakened by distance. This is the fire itself. Let's start with just the surface of the sun. It glows at around 5,500 degrees Celsius. Remember Venus at 460? The sun's surface is more than 10 times hotter than that. At that heat, there's no surviving, no melting, no burning, no time to feel anything. You'd be instantly turned into a puff of glowing gas. And here's a twist. The surface is actually the cool part. Just above it, things get strangely hotter. The sun's outer atmosphere, the corona, soars to over 1,000,000 degrees. Scientists still puzzle over exactly why, but the real monster is hidden deep inside. Because the core is where the true furnace really burns. At the sun's core, the temperature reaches a staggering 15 million degrees Celsius. It's so hot down there that the very atoms get smashed together. They fuse into new elements, releasing the light and warmth we all live by. Every bit of warmth you have ever felt, every sunny day, traces back to that 15 million degree heart. And yet, against the whole universe, our sun is just a small, ordinary, fairly cool little star. Because out there, our sun is a candle next to some truly monstrous stars. The hottest stars don't glow gentle orange or yellow like ours. They blaze a fierce electric blue-white. And here's the rule that flips everything. In space, blue is hotter than red, the opposite of what feels true. The surfaces of the hottest blue stars can reach tens of thousands of degrees, dwarfing our sun. But even those are nothing compared to what a star does when it finally dies. When a giant star finally runs out of fuel, it can't hold itself up anymore. It collapses and detonates in a supernova, one of the most violent events in all the universe. For a few seconds, the blast reaches billions of degrees and shines brighter than an entire galaxy. One dying star, for one brief instant, outshines 100 billion suns. That's how violent heat can get. And what's left behind can be even stranger. A neutron star with a surface of around 1,000,000 degrees. And believe it or not, even a supernova is not the hottest thing the universe has to offer. So after all of that, what is the single hottest place in the universe? To find it, we have to think about heat in a completely new way. So here's the secret. Heat is really just movement. The faster tiny particles slam around, the hotter something is. So to make the hottest place imaginable, you just need to slam particles together as hard as physically possible. And astonishingly, we have already done exactly that. Not on some distant star, right here, on Earth. In a giant machine that whips particles to nearly the speed of light and crashes them head-on. When they collide, for the tiniest sliver of a second, they create a spark hotter than anything in nature. We measured that spark at over 5 trillion degrees. Just stop and let that number sit with you for a second. That's hundreds of thousands of times hotter than the core of the sun. And here's the wildest part. It's the same kind of heat that once filled everything. The entire universe in the very first instant after the Big Bang. So the hottest place in the universe isn't a star or a planet. It's a spark we made that lasted a heartbeat here on Earth. Now let's come all the way back down, all the way back to your body, on a hot day exactly like today. Because you don't need a star to be in real danger from heat. A bad summer day is enough. Your body's #1 tool against heat is something you barely think about. Sweat. As it dries off your skin, it quietly carries your warmth away with it. It's the very same trick the spacesuit uses. Turn a liquid into vapor and it steals heat as it goes. But sweat has a breaking point, and in a humid heat wave it fails. When the air is hot and soaking wet, the sweat can't dry and the cooling just stops. Then with the cooling gone, your core temperature starts to climb, and this is where a hot day turns genuinely dangerous. Past about 40 degrees inside, your brain and organs start to cook. This is heat stroke, and it's a true emergency. There's also a hidden killer scientists watch called the wet bulb temperature, the point where sweat can't save you at all. Cross that line even in the shade, and a healthy human simply cannot survive for long. That's how serious heat is. So in this heat wave, please take it genuinely seriously. Drink water before you feel thirsty, find shade, and slow right down. And here's a question for you. What's the hottest temperature you have ever actually felt in your life? Tell me below. So let's put this whole journey together. We started way down at 50 degrees, the very edge of an earthly heat wave. Then Mercury at 430, Venus at 465, re-entry fire at 1600, the sun's surface at 5,500, its core at 15 million, a supernova at billions, and finally 5 trillion degrees in a spark we made ourselves. The hottest moment in all of creation. Now notice something strange about that entire list. Every single number on it would kill you instantly. From the gentlest re-entry to the fiercest star, not one of those temperatures would let your body last a second. And then there's the one temperature that doesn't. The gentle, ordinary warmth of a summer day on Earth. Earth sits in a tiny, perfect band of temperature, warm enough to keep water liquid, cool enough to let life hold on. A few degrees hotter, like Venus, and our oceans would simply boil away. A few degrees colder, and those same oceans would freeze solid. Of every place in the entire universe, this one tiny warm spot is the only one that actually fits your body. So tonight, when the heat is keeping you awake and your pillow is too warm, try, just for a second, to remember this. Yes, it's hot tonight. Maybe miserably so. But it's the exact kind of warmth the rest of the universe would do anything to have. You're sweating tonight on the one perfect spot in all of creation. So drink your water and try to stay cool. Next time, I'll take you to the coldest places in the universe, where the heat finally completely runs out.